Hey, real quick. All right, let's go through a couple quick review. Okay, I know this is going to seem a little redundant. Hey, all right, convert pi over 180. Convert using 180 over pi. These can be decimals, these two, number 3 and 4. 5 and 6, remember you need 2 answers per problem. You're finding coterminal angles, add and subtract. The next, 7 and 8, the formula is on the actual practice guide. Okay, it will be there test day. Hey, I'm not going to stop. I'm not going to stop all the time. You guys got to stay quiet for now.
Are you going to put the radian thing on there or no?
No. Alright, 9. This first answer is cosine, the second answer is sine. And then you can go find tangent if you set up the triangle using these. The triangle's almost set up here in the second quadrant. You got to fill in the numbers using, opposite and adjacent hypotenuse. 10, 11, you're just doing the cofunctions. You're not typing those in calculators. The only thing you'd probably need to is if you need to convert the angle. But I will have the pairings on the board for cofunctions. These are the only 2 problems that you use cofunctions on. Okay, the other ones you use reciprocals. So keep that in mind. Okay, 12 and 13, these are the ones you had to type in your calculator yesterday, that you have the inverse buttons to find the angles. 14 we did yesterday in class, you had to find the length across the lake. 15, you had to find the angle. This is where you have to use the inverse button on your calculator as well. I will not guarantee that your story problems will be finding the same markers. They'll just be a story problem of some sort that I picked from your book that you had. Okay? Alright. 16, 17. These, we started 16 yesterday, we finished it. Today I want to start with 17 and kind of work our way through the end. We're not going to do every problem, but I'll pick 1 or 2 of each. Or 1, I should say, of each. Of the type that I want. Now, obviously with 17, I'm going to get you started on it, and then I'll have you finish it. The reason being is that the clues don't necessarily tell you right away what quadrant you're in. So we got to kind of figure out how to like navigate those clues.
Tangent is negative.
Yep. And then 18 and 19, we're finding the reference angle. These are finding the exact values. This is where it'd be really helpful if you have your property sheet and or your special triangles on that property sheet, because we're going to use those. And then 20 and 21, these are the drawings. We'll get down to one of these today. I'll kind of help you look at them, and we'll do one together, and then the other one I'll just kind of give you a clue on how to do it. Okay? Alright, but let's start with 17 and kind of work our way to the end here. This one, they're giving you enough clues to figure out which quadrant you're in so you can draw the picture and then figure out the remaining trig functions. You pretty much know 2 trig functions as it sits because of the way that the numbers are. That this is tangent, you know cotangent as well. I'm obviously not in the 3rd quadrant, and I'm not in the 1st. The reason why I know that, tangent is negative. So if I'm thinking about the quadrant, we're not here, and we're not here. Okay, sine is positive, it's greater than 0. Second. From this quadrant. The reason being, sine is positive in this quadrant. If you look at your positive negative sign chart, that's a chart you should have in your notes. Or on your property sheet as well, that sine and cosecant are positive in the second quadrant. And how I looked at this, tangent's negative, sine was positive. That's how I knew what quadrant I'm in. So I'm in this quadrant, this is where theta is going to be, it's always next to the origin, and we're always bringing the triangles back to the x-axis. That's how I always draw them. Doesn't matter which quadrant you're in, they always go back to the x-axis. Now that I'm here, now I can set up tangent. Tangent is the opposite over adjacent, and one of these numbers is negative. It doesn't matter that the top is negative on that fraction. You can put the negative anywhere you want. In fact, the 3 is actually the negative number. Because in the second quadrant, you go over negative, up positive. So, and how I know that, this is the opposite wall for your angle, and this is the adjacent wall. That's how I know where the numbers need to be plugged in. Now, if I do the Pythagorean theorem, I can figure out this missing wall. So 2 squared plus negative 3 squared, which you don't need the negative because you're squared anyways, equals the hypotenuse squared. This is 4 plus 9 equals the hypotenuse squared, which is, what, 13?
Yeah, which is 3.6055.
All right, leave it a radical. I do want the exact answer. I don't want decimals. So what you have here, when I took the square root of it, that's how you get h by itself. You will have to do that on your problem. Okay, you're going to have to do that, especially like on 16 we did that as well, doing the Pythagorean theorem. And now that I have all the walls marked, now I can go after every trig function from this angle here. So I can go after sine, cosine, tangent. So let's go after the first two, sine and cosine. Then you can do the reciprocals on your own. All right, and tangent. Tangent you already have. If you get tangent wrong, there's no hope for you. Like it's printed on the paper. You shouldn't get that one wrong.
Well, you have to write that?
Yeah, you have to write them all. So you got to give me all the trig functions. So we got tangent, we already know that one. And the reciprocal do it, which is cotangent, you already know that one. Now, for the other ones, I'm just going to get the first two set up. Then you can find the reciprocals. Reciprocals are cosecant and secant, respectively. And yes, those will be listed on the board tomorrow so you know which ones are paired. Which is easy, because every trig function is paired with one that starts with the letter C. That's how it always works. So sine is opposite over hypotenuse, so that's 2 over root 13.
Yep.
And that is positive, because you're in that second quadrant. And then cosine is negative 3 over root 13. Now, I do not expect you to simplify that, like rationalize it by putting the radical on the top and bottom. I don't care about that. As long as you have the original fraction set up, I'm fine. Don't put decimals, leave them radicals, all that good stuff. The big thing I'm checking for is, do you have the right numbers in the right spots? And do you have the right negative signs on them? You know, positive or negative sign, I should say. Since you're in the second quadrant, you know, sine and cosine should be the positive ones. Okay, questions? All right. You'll have to finish 17 on your own, because I did the first half, which is all the hard part. Now you can finish up the second half on your own. You don't need to rationalize, you can just leave them like those, but then you have to find the other three. Questions? Okay, moving on. Hopefully that made sense. The clues that were given to you, you had to put both clues together to figure out the quadrant you're in. If you do not have the positive negative sign chart on your property sheet, that's something that maybe today you want me to write down. I'll put it on the board somewhere so that way you can get it copied before tomorrow. You do need your property sheet. It is one of those things I will not let you leave here once the test started to go get that property sheet. And no, you're not going to conveniently go to the bathroom. Oh, I need to go to the bathroom. Yeah, no.
Crap.
So be ready to go. So go to the bathroom before you walk in, before you start. Okay? Because if you don't have that property sheet, you don't get to go get it. You have to come in here prepared, ready to go. We only have so much time to get to take this test. All right. Let's move on. Okay, we're doing 18, 19. I'll do one of these for you. Is there a certain one?
Yeah, because there's a pie and it's
18?
all like
okay. All right. So 18. We're going to convert this one before we start. Now this one, I believe this one, it'll be beneficial if you have your property sheet. But we'll talk about it still. We're gonna convert this angle. I know it says don't use a calculator. I'm going to convert. I need to know what the angle is because I don't like using radians. Me either. So I'm going to multiply by 180 over pi. Yeah. The pi's cancel. 180 divided by 3 is 60, and then you take it times 2, so this is 120.
Why wouldn't you just take?
All right. Now I know it's on your property sheet, but I like to convert it to angles. Now that we know it's 120, I can draw what quadrant I'm in, so I can find my reference angle. And then the reference angle gives me the right triangles, the special ones. And those special triangles should be on your property sheet. If you don't, I'll put those on the board so you can copy those down. So we're 120 degrees. That means I'm in the second quadrant. I'm in the second quadrant. The angle is always next to the origin. 120 degrees is technically a 60-degree angle in here. This is your reference angle. Now how I know that is because the 120 is on the outside, and it has to add up to 180 because we're going to the x-axis.
Per se.
Okay. Okay, now that we have that, now I can fill in the special right triangle because it is a 30, 60, 90 triangle. So the side opposite of 60 is root 3, the side opposite of 30, this is 30 up here, that's 1, the side opposite of 90 is 2. That's your special right triangle, bless you, whoever says. Alright, now, one of the numbers is negative, and that's the negative 1, because you're in the second quadrant, so one of the numbers is negative, it's going to the left. Again, the special triangles, the side opposite of 30 is 1, side opposite of 60 is root 3, the side opposite of 90 is 2. The only other triangle you could have is a 45, 45, 90 triangle, 1, 1, root 2.
What is it actually asking for?
Now, what it's asking for is to find the exact answer for that trig function on that triangle. So now that I have the numbers on the triangle, I can read off what the sine of that angle is. The sine of 120 is the same as doing the sine of 60 on that triangle. So that's what I'm going to rattle off. The sine of 60 is the same angle. That's called a reference angle. It'll give me the same answer in that picture. So sine is opposite over hypotenuse. So that is root 3 over the hypotenuse, which is 2 on that triangle, and we're done. Move on to the next one. And it is positive because we're in the second quadrant.
Cool.
Again, that's the exact answer. No calculator needed, unless the only thing that you'd probably need if you need to like convert the angle back. I can understand that. Like the next one, like I would subtract 360 to figure out what that smaller angle is. But once you have it, then you can draw it whatever quadrant it's in, and then you can figure out what special triangle it is. Now, when you do the secant on this next one, my little clue is, figure out what the angle is. It's a full circle and a little bit extra. So whatever angle that is, you're going to find the cosine's answers first, cosine, and then since we're finding secant, whatever the cosine answer is, just flip it over because it's a reciprocal. So just flip the answer over. It's still negative or positive wherever quadrant's in, but you just flip the answer over. So that's how you find secant. It's exact answers, no calculator. If I get a decimal on that problem, because you just typed it in your calculator and hit enter, I count it all wrong, you don't get any of the points for it. Because I want the exact answer and you had to show me the picture where it's at. Now, if it lands on a quadrant, on a perfect quadrant angle, they're on your property sheet.
What?
You have quadrant angles. Okay, you have 90s, 180s, 270s. They have the cosine sine answer on their property sheet, so you can set up your answer from that.
I know this decimal point if I go at it.
I think I'm just going to give you normal angles you can find.
Write that down.
So.
Write down that.
Okay, questions?
Write it down.
You're not going to do that stuff
For what?
So it's root 2 over 1. Negative. On the negative. You're not going to do that.
Did you get that?
You're not going to do 2 pi.
No.
Just normal.
No, I would expect a normal angle.
Now compare these two digits.
I just put that on there just in case you were wondering.
Nice job, Mr. Ward.
Okay,
Are they the same?
questions?
Mr. Ward, those are exactly the same if you do it to a decimal.
2 decimal. Okay.
Like to the 9th decimal.
I want the exact decimal.
That's the exact answer. It's the same thing. If you square it, they're the same.
It's a decimal, not a fraction.
But it's the same thing.
It's an approximation.
No, it's not.
It's the exact.
What's 1 divided by 2? It's 0.5.
Yeah, that's exact. But if it goes 9 decimal places,
What
that
if it
means
goes
there's
9
probably
decimal
more
places?
past it.
But what if it's 9 decimal places and stops?
Well, how do you know it stops?
How do you
Because
know
it
it
doesn't
stops?
go on any farther?
All I know is that if you take the same thing, put your calculator, do that, it's equal. So decimals count.
Alright, here we go. Moving on. Let's go on to 20 and 21. Alright, 20 and 21. Now, if there's one specific one you'd like me to do here, I'll do it for you. I'll give you clues on the other ones. So, which one do you want?
20.
20. Okay, we'll do 20. I'll give you the clues for how to do 21 here in a minute. Okay, 20. These are the wave graphs. Okay? The ones I'm going to test you on are just the basic ones. I'm not going to have it shifted right or left.
Thank God.
I'm not going to do that. But I will test you on sine, cosine. I'll test you on tangent or cotangent kind of a thing. Cosecant and secant I'm probably not going to put on there.
Thank you.
I'll just put the normal one.
That was
So
hard.
if I was expecting one, if I was going to expect one on the test, sine, cosine, tangent.
But
That's your hint.
cotangent.
So I know.
That's pretty.
All right. Now, let's walk through this first one. So what this is the actual amplitude. So my waves are about 3 in height. This affects the period, and this affects the actual shift, the origin line. The center of my graph, where it's centered over. Okay, the reflective line, if you want to call it a reflection line. But anyways, cosine, it looks like it's being shifted up to. I'm going to work with the shift first. So this number, since it's +2 and that's outside the parenthesis, they don't have a parenthesis with it in it. So it's outside, so it's been shifted up to +2. That means from that line, this origin line, that's where the waves will hit. So I'm going to go up 3 from there. So I'm going to hit a total of 5. And I'm going to go down 3 from there, which is 1, 2, 3. So it's what, -1? So those are my peaks and valleys I'll hit off of the origin line. Now again, how I did that is knowing where my origin line is, the amplitude is from there. So that's why I'm going to hit 5 and -1, because I'm going 3 up and down. Now the negative sign means the graph is flipped upside down, so instead of cosine starting at the topmost point, it's going to start at the lowest point and go up. So it's going to be like, instead of a U, it's going to look like an N. But then the 4 marks going across, Normally we go out to 2 pi. That's normally the period for sine, cosine, cosecant. But since we're dividing by the number in front of x, it looks like my fourth marker is going to be a 1. Because you take 2 pi divided by 2 pi. And then cut that in half it again, multiply that by 3. So these are the markers going across.
Woo.
So now I'm going to draw a cosine, and it's negative, so it's upside down. So cosine is going to start, instead of starting at the highest point, it's going to start lowest, come back up to this marker, go to its highest point, come back to the marker, come back to its lowest point. So it looks like an N, not a U shape, because it's negative, so it's upside down. So, but there you go. Okay, so there's your cosine graph. If it was sine, let's say it was the same problem with sine. Sine, it would be shifted up 2. Jesus, fucking terrible.
You're also
So we've shifted up, 3 spots from there, down 3. But sine normally starts at here and goes up and down. But sine would do this. That'd be sine if it had a negative sign out front.
Oh my goodness.
It'd be the same type of picture, but it would just be flipped over because of the negative sign.
That is incredible.
Okay, questions about sine or cosine graphs? Okay, remember, the period is 2 pi normally. Okay, let's go to the last one. Your last problem. This graph is not being shifted up or down. The waves are definitely being affected, where the markers are, and the period length is. Now, cotangent, your only clue here.
This is the weird one, isn't it?
This is the weird one. This is the not centered over the origin, but the idea here is that the period is no longer 2 pi. All right. So let me walk you through this. All right. For cotangent. Cotangent is actually like to the right of the origin. It's not centered over the origin like tangent would, but the actual like fourth marker down the road for cotangent is pi, not 2 pi. So if you have a number out front like yours, you're gonna have to divide by that, and that would be your fourth mark. So you're gonna take pi divided by that number. That's your fourth mark. Then you cut in half, then cut in half, and multiply by 3. Now the markers. Normally you hit 1 and -1. Obviously you guys aren't going to be hitting that because there's a half out front. So that's your new marker. Then there's asymptotes on the outside, which you have to worry about. Yes, you do have to fill in the asymptotes the best you can. And then when you draw cotangent, cotangent will start in the upper left corner and work its way down like such.
Wait, so do you what?
What's the half?
The half is affecting amplitude. So I just said a
Does
little
it
bit
make
ago.
it go up 2 or half?
Half.
I
Half.
can't see the graph.
Is that
Half is tall.
Do you have to move the origin there?
What? We're not moving origin on this one.
Wait, so the -1 is now a half, or? I'm confused.
Yeah, oh yeah. So yeah, on yours, these markers would be shrunk by half. So they're
half.
compressed. Half is tall.
So it's just a half.
Okay, but that's cotangent's graph. Sorry, it's a little faded. My markers are dying up here.
Is this
All right. But there you go. Make sure.
So we need to put the other ones on there though.
Yeah, you need to put the new numbers in there, all the marks, all that. Now, I'm going to warn you. I could put a sine, cosine, or tangent graph up here. If I'm going to give you tangent, you better be well aware of how those work, because the markers across are very different. Okay? All right, so that's it for today. You have the rest of the time today to kind of study this. You're ready to go. Give me that.
Larson told me he wouldn't see it. What?
What?
Blame me right now.
Anyway.